Dear students, let us start with our third part of the lesson. We will learn on testing the association of attributes through numerical illustrations. Now, I can go for the problem. As you have been went with the theories a lot, now we can go with the numerical illustration. First of all, be clear about the problem, that what type of problem you are going to study. That is, in a chi-square, you have been went with two different models earlier, that is using regression model, then you went with using an probability distribution. Now here you come over for the association. So in everywhere you have to follow the 5 steps commonly, which I mentioned earlier. Be clear about that. That is, the first thing is that H0, that is your null hypothesis. The second thing is alternative hypothesis H1. Then third, you have to go for your alpha, that is your level of significance, and your degrees of freedom. Then fourth, you are go for your calculation of your chi-square test. At the end, you are going to infer. These are the common 5 steps which you have been following for the test statistic. Now we go for the problem of testing of association. From the following data, find whether there is any significant liking in the habit of taking soft drinks among the categories of employees. So here you have been categorized two different things, that is employee and soft drink. Under the employee, you went with clerks, teachers and officers, whereas in the soft drinks you went with the 3 different drinks as drink A, drink B, drink C. As mentioned earlier in the cases, your numbers will speak 2 representations. Now we can see that the 10 will speaks about that 10 number of clerks will like soft drink A, whereas in the 25 will represents that 25 number of teachers like drink A, whereas in a 65 represents that 65 number of officers like drink A. Like that you can go with the interpretation of each and every number. That is, the 30 will speaks that 30 number of officers is liking drink C. You have to understand with this your contingency table. Now coming to the solution, first what you have to study here, you have to be clear about your problem, what you are going to study. So in this problem, you have to study if there is any significant liking in the habit of taking soft drinks among the categories of employees. You may be thinking, so why you are studying about these liking habits of the person? So which impacts the market into the higher level? As you know that which soft drink is most liked by the person will be having the most sales. So you may not think about the problem as a simpler one which reflects in an business models. So as usual, the first step will be your null hypothesis, and you have to frame your null hypothesis according to your problem, not simply or generalized version. That is, there is no significant liking in the habit of taking soft drinks among the employees. Definitely alternative hypothesis H1, there is significant liking in the habit of taking soft drinks among the employees. Earlier in our null and alternative hypothesis, simply we will be giving as there is no significant difference between observed and expected frequencies, but here the problem is specific, then you have to go with your problem based statement. Now you completed your first 2 steps. What will be the third step? Level of significance alpha, that is your 0.05, and your degrees of freedom. Here there is a minute correction in your degrees of freedom. Earlier it is simply n minus 1, that is your number of observations minus 1. What about here? It will be number of rows minus 1 into number of columns minus 1, because it is a contingency table and you have to work out accordingly. You are having m minus 1 into n minus 1. You can see over here you have been went with 3 different categories of employees and 3 different categories of soft drinks. As you see earlier, clerks, teachers, officers are the 3 categories for the employees, and drink A, drink B, drink C are the 3 categories for the soft drinks. So 3 minus 1 into 3 minus 1 automatically. It means that 2 into 2 the value will be 4. This is your degrees of freedom. Now you completed your third step. Then what will be our fourth step? Automatically you have to go for your calculation of expected frequency. Before that you have to confirm your observed frequencies with the total, because these total will impact your expected frequencies. Now you can see here, this is your table again, and you have been made the total for all these values. So 10 plus 25 plus 65 the value will be 100. Similarly 15, 30, 65 the total will be 110. The third row total will be 140. Now I can see the column wise total 75, 115, 160 and the grand total will be 350. That is totally 350 number of persons data has been collected. As I mentioned, each number will speaks a category, whereas here the 10 will speaks about that 10 number of clerks are liking the drink A, which I mentioned earlier. Now here you can see the total, the 100 speaks that how many number of persons are liking drink A has been given as a total here 100. Similarly 110, 110 is speaking that how many number of persons are liking drink B. Similarly 140 number of persons are liking drink C. Now you can see the column total here, how many number of clerks are liking the particular drink, soft drinks, that is 75. You can specify that how many of are liking soft drinks or not, that you can see over here in 75. Similarly 115 number of teachers are liking, 160 number of officers are liking to have a soft drinks. You can mean that the others may have an option of taking a coffee or tea, that is they may go for the other drinks. You can see with this data. Now again, before going to your expected frequency calculation, be clear about that these are all the totals you are going to use for the calculation. That is, suppose if you want to calculate the expected frequency for the 10, what will be the formula here? The corresponding row total into corresponding column total divided by grand total, that is your formula. It means that 100 into 75 divided by 350 will gives your respective expected frequency. Let us suppose I can make you the example as for 60. For 60 the corresponding row total is 140, corresponding column total is 115 and the grand total is 350. So the expected frequency for this 60 can be calculated as 140 into 115 divided by 350, where you can obtain your expected frequency. I hope you can understand. With this total you can get, and again after calculating all the expected frequency for these values, the total should be matched with these one only, that is 100, 110, 140, similarly 75, 115, 160, these values has to be mentioned. Let us see in a calculation of expected frequencies now. As I mentioned, the row and column totals, it is 100 into 75 divided by 350, that is 21.4. This is your first expected frequency. Similarly here 100 into 115 divided by 350, 32.9 is your second expected frequency. This is your third, fourth, fifth, sixth. Similarly you can move on with here 140 into 160 divided by 350, which will be value as 64. Now we can compare that by adding all these values. You have to get your previous row totals as like in your observed frequency. Don't get confused that you have been taking these values, the 100 and 75 as not taken here, the values as taken from your observed frequency total. You have to be clear about that. And also you can think about here the row totals and column totals has been matched properly with the total grand total of 350. Now you obtained your expected frequencies through your observed frequencies. In earlier cases you have been went with an probability distribution you based on the probability. By multiplying your total frequency to the probability, you got your expected frequencies, whereas in your regression model you went with the fitted models, then only you get your expected frequency. So be clear about that, how you are computing your expected frequency, that is 3 different methodologies to calculate your cases. From the above tables of observed and expected frequencies, now we can go for the calculation of chi-square test statistic. Just I have placed the values as in a column. Here you have to remind that while making the numbers here, you should be clear how to get the values. In a table you have to go in a row wise, that is first row values has to be kept first, that is 10, 25, 65. Then second row has to be kept next, 15, 30, 65. Then third row has to be kept next, that is 50, 60, 30. The order should be followed properly. You cannot place your order in a other manner. Similarly, the respective expected frequency has to be placed properly, that is the first row 21.4, 32.9, 45.7 has to be kept first. Then the second row 23.6, 36.1, 50.3 has to be kept next. Then third row 30, 46, 64 has to be kept next. Defaultly the totals of observed frequency and expected frequency has to be matched, that should be clear. Suppose you may have a doubt, sir, whether our expected frequency has not mapped with our observed frequency, then you have to verify your calculations. So definitely, that is exactly it will be matching with the total. Now coming to the calculation of chi-square value, as you know, with the formula of chi-square as summation OI minus EI whole square by EI, you can see that 10 minus 21.4 whole square divided by 21.4, which reflects as 6.073, which is your first chi-square value. Similarly, you can go with 25 minus 32.9 whole square divided by 32.9, where you can go for 1.897. Similarly, you can calculate for all these values. At the end, 30 minus 64 whole square divided by 64 will obtains as 18.062. By summing up of all these values, you can obtain your chi-square value as 60.238, which is your chi-square calculated value. As you know, the formula as summation OI minus EI whole square by EI. This is your chi-square calculated value 60.238. By using the following chi-square formula, we can calculate the cases. Just I have been represented the formula again for your reference here. The chi-square critical or table value is 9.49. Here earlier you calculated our degrees of freedom as number of rows minus 1 into number of columns minus 1, that is 3 minus 1 into 3 minus 1, the value is 4. So for chi-square 4 degrees of freedom with 5% level of significance, you got the table value as 9.49. Just you can go for the table here how you have been working. You can see the degrees of freedom here, and you are going for the 4 degrees of freedom, and you can go with the 5% level of significance, and you can obtain the value as 9.49, which is your chi-square critical value. Now we can compare this chi-square calculated value and critical value. Here you can see that your chi-square calculated value is greater than the critical value, then we will automatically reject our null hypothesis H0, and we can conclude that there is a significant liking in the habit of taking soft drinks among the employees. So in the calculation part here, after in concluding, you have to be clear about that what you are going to perform, that is whether you are giving a significance or you are giving a non-significance. So while making the calculations, be remind about the 5 steps how you have been performing. We have come to the end of our lesson. In the lesson, we have went with 3 different parts. In the first part, we went with the computation of chi-square, goodness of fit in through regression models. Then in the part 2, we went with the computation of chi-square test, goodness of fit in probability distributions. In the third part, we went with the computation of chi-square test, goodness of fit in testing of attributes. We all went with the 3 different problems, and I am confident that you understood all the 3 illustrations which have been covered here. We have concluded our lesson interpretation of outcome of a chi-square test. Thank you.